Good morning friends. Today we discuss about one topic of application of partial differentiation. We check the part. Our topic is error and approximation. We discuss about different types of errors, some examples regarding to errors, and some approximation value by this topic. First topic, error determination. There are three types of error determination. First one, when we take modulus of delta x is known as an absolute error. Then delta x by x is known as relative error, and if delta x by s means if relative error multiplied by 100, that is known as percentage error. Okay. So, in this chapter we discuss about three different types of error. First one, mode of delta x, that is absolute error. Second thing, delta x by x, that is known as relative error, and third thing, delta x by x multiplied by 100 is known as percentage error. The question is how to find the formula of finding error. Okay. So, if you have any function f of x y, means a function in terms of x and y be a continuous function of the variable x and y, let delta x and delta y be the increment in x and y respectively, then new value of f of x y will be f of x plus delta x comma y plus delta y. So, if x replaced by x plus delta x and y replaced by y plus delta y, then new value will be f of x y is f of x plus delta x comma y plus delta y. Now, change in delta f, it is known as delta f is equal to f of x plus delta x comma y plus delta y minus f of x y. Means how to find the error? We have old value, that is f of x y, and after increment in x and y will new value be f of x plus delta x comma y plus delta y. So, what is change here? Change is f of x plus delta x comma y plus delta y minus f of x y. Now, how to find the formula of this? Expanding f of x plus delta x comma y plus delta y by Taylor series expansion up to first order. So, we have change in f is equal to delta f by del x into multiplied by del x plus del f by delta y into del y. So, this is the error formula. Change in the variable function f, this is equal to del f by del x, means derivative of f with respect to one variable x into change in x plus derivative of f with respect to y into change in y. It is only for two dimensions. Sometimes we have a function which collection of two or more functions. Now, we discuss about the first example. The example is the period of a simple pendulum is t 2 pi into root of L by g. Find the error in capital T, means we find the error in a capital T, that is the period of that due to possible error up to 2% in the length L and 1% in G. Okay. Now, for this two data, this is the formula of finding simple pendulum period t is equal to 2 pi root L by root G, means t is a function of L and G. We have two variable N and G. So, change in t means partial derivative of t with respect to L multiplied by change in L plus partial derivative of t with respect to G multiplied by G, change in G. Now, according to data, delta L is given 2% in L, means it is 2 L by 100. Change in G is given 1% in G, so that will be G by 100. Now, here the first term is delta t by del L, means derivative of t with respect to L, as we know that t is a function of 2 pi root L by root g. Here we take partial derivative with respect to L first, that is why 2 pi upon root g common. Now we take derivative of root L, that is 1 upon 2 root L into, now value of delta L, that is given here 2L by 100. So 2L by 100 plus, now the derivative of t with respect to g partially, so 2 pi common, root of L common. Now we take derivative of 1 by root g, as 1 by root g, that is equal to g raised to minus half. So if you find the derivative of this, then that will be minus 1 upon 2 g raised to 3 by 2 into change in g, that is g by 100. So this is equal to cancel here. So 2 pi L upon root L, that is root L upon root of g multiplied by 1 by 100 minus 2 pi root of L, g is here in a denominator g raised to 3 by 2. So it will be root of g multiplied by 1 by 2 into 100. Now by the formula we have t is equal to 2 pi root of L by g. So first term is t by 100, in second term 1 by 2 common, and remaining term is t by 100. So this is equal to 1 by 2 t by 100, means 0.5% change in capital T. Okay. So according to this data, if t is equal to 2 pi root L by root g, where change in L is given 2%, means 2L by 100, change in g, that is 1% in g, that is g by 100. So if we find the total change in capital T, that will be 0.5% in T, means 1/2% of T by 1/2% of T. Now we discuss about next example. So we discuss here next example, find the possible percentage error in computing the parallel resistance small r of the two resistance R1 and R2 from the formula 1 upon R is equal to 1 by R1 plus 1 upon R2, where R1 and R2 are both in error by 2% in each. Okay. So here two resistance R1 and R2 are given in the parallel line. So we find out change in small r. We find out change in small r. Okay. R1 and R2 both are percentage in error by 2% in each. We discuss in the again by the blackboard. Formula is 1 by R is equal to 1 upon R1 plus 1 upon R2. This is the formula for finding resistance R, where R1 and R2 are given. Means according to this, R is a function of R1 and R2. R is a function of R1 and R2. According to question, delta R1 is given 2% in R1. Delta R2 is also given 2% in R2, means both are equal to 2 R1 by 100, and second thing will be 2 R2 by 100. So change in R1 and change in R2 both are given. Now we find out change in R. So according to this, change in R is equal to derivative of R with respect to R1 into change in R1 plus derivative of R with respect to R2 into change in R2. As R is a function of R1 and R2, so here we take partial derivative del R by del R1 into change in R1 plus del r by del r2 into change in del r2. Now, we have the value of del r1, that is 2 r1 by 100. We have the value of del r2 by 100, but we have no value of the derivative. Now, given that 1 upon r is equal to 1 upon r1 plus 1 upon r2. Here r is a function of r1 and r2. So, we take partial derivative, partial differentiate, partial derivative of r with respect to r1, partial derivative of above equation with respect to r1. So, derivative of this is minus 1 upon r square into del r by del r1, as r is a function of r1 and r2. That is why del r by del r1 is equal to derivative of r1 is minus 1 upon r1 square plus, as we take partial derivative with respect to r1 only, that is why second derivative 0, because that is not containing r1. Therefore, del r by del r1, that is equal to r square upon r1 square. Del r by del r1, that is r square upon r1 square, means r square upon r1 square into change in r1, that is 2 r1 by 100. So, 2 r1 by 100 plus, in this 1 upon r is equal to 1 upon r1 plus 1 upon r2. We take partial derivative with respect to r1 only. At that time we have del r by del r1, that is r square upon r1 square. So, similarly, if we find out del r by del r2, so from this equation that will be r square upon r2 square, r square upon r2 square, r square upon r2 square multiply by change in r2, that is 2 r2 by 100. So, 2 common from the data, r square common, 100 common, 2 common from the data, r square common, 100 common. So, in the first one 1 upon r1 plus in the second one remaining term 1 upon r2. So, this is equal to 2 r square by 100 into, but 1 upon r1 plus 1 upon r2 is according to data, it is 1 upon r. So, we put here 1 upon r. So, this is equal to 2 r by 100, meaning of this 2% in r. So, question is 1 upon r is equal to 1 upon r1 plus 1 upon r2. If we take change in r1 and r2, both are 2%. So, in total resistance r, change is also 2% in r. Now, we take third example. The base radius and height of a right circular cone are measured 10 centimeter and 25 centimeter respectively, with a possible error in measurement of as much as 0.1 centimeter in h, means if you count the radius, then there is a 0.1 centimeter, as well as in height, that is also 0.1 centimeter. Estimate the maximum error in the calculated volume of the cone. So, as we know that volume of a cone 1 by 3 pi r square h, means 1 by 3 is the constant, pi constant. So, remaining r and h, means volume is a function of r and h, where according to data given that r is equal to 10 centimeter and the change in r1 is given 0.1 centimeter. Height is given 25 centimeter and change in height is also given 0.1 centimeter. Okay. So, here V is a function of r and h. So, by the formula, change in V is equal to del V by del r into delta r plus del V by del h into delta h, as V is a function of r h. So, we take partial derivative with respect to r and partial derivative with respect to h. Now, volume of a cone, that is 1 by 3 pi r square h. So, if we take derivative with respect to r, then 1 by 3 common, pi common, h common. So, derivative of r square is 2r, and if we take derivative with respect to h, then 1 by 3 common, pi common, r square common, and derivative of h with respect to h is 1. So, del v by del r, that is 2 by 3 pi r h into delta r plus 1 by 3 pi r square into delta h. As according to data, value of radius is given, pi by 3 common from the data. 2. Radius of the cone is given 10 centimeter, height is also given 25, and radius square, that is 100, multiply by delta r and delta h both are equal 0.1 centimeter. Okay. So, for this calculation, this is 500 plus 100, 600 divided by 3. So, result will be 20 pi centimeter cube. As we find the change in volume, that is why it is 25 centimeter cube. Next example, if the kinetic energy T is equal to mv square by 2, find the approximating the change in T as m changes from 49 to 49.5 and V changes from 1600 to 1590. In the previous question, all the data error is given, but in this one error is not given, but we find error from the given data at initial stage and after some stage. By the formula, T is given 1/2 mv square, where m and v are variable. So, T is a function of m and v. Value of m is given, that is 49. Value of m is given 49, and m is also changes from 49 to 49.5. So, how many changes in m? That is the next value minus old value. So, 49.5 minus 49, that will be 0.5, which and v is given 1600, that is the starting value, and if we find the change, then 1590 minus 1600, that will be minus 10. Okay. So, here m is given 49, v is given 1600, change in n, that is 0.5